What if your night sky got a software update? Imagine the moon, our soft nightlight, outfitted with massive mirrors or millions of tiny reflectors so it could steer extra sunlight down to Earth. Some people pitch this as a tool to help Arctic farmers, reduce winter darkness, or even nudge more light onto solar farms. But flip that switch in the sky and you don't just change light. You change ecosystems, politics, equity, and the rules for how we share a common celestial neighbor. Quick framing. This video explores scientific proposals, modeled scenarios, and policy trade-offs. We're not proposing a deployment plan. Instead, we'll examine the engineering, the climate claims, the legal questions, and the unexpected side effects, using published science and expert voices where possible. Wherever we show vivid scenes, those are illustrative scenarios labeled as speculative. First, what exactly is a lunar reflector? Shit meta. At its core, the idea is simple. The moon already reflects sunlight. The question is, can we increase or redirect that reflected light deliberately by placing mirrors on the surface, deploying swarms of reflective satellites around the moon, or inflating huge panels in lunar orbit? Each option looks very different. Surface mirrors would be anchored and fixed. Orbital swarms could steer light more precisely. Inflatable reflectors could be lightweight but fragile. Practically, the crucial parameters are the mirror area, the reflectivity of the material, the incidence angle, and the vast distance, roughly 384,000 kilometers between the Earth and the Moon. Those parameters determine how much extra lux, that is, how much brightness, can be delivered at particular latitudes and times. The engineering math is where optimism meets reality. To give you an idea, to change nighttime illumination in a useful way across large regions, you need enormous reflective area. Think millions of square meters. And precise pointing. That implies either shipping massive mass to the moon or launching swarms of tiny reflectors by the thousands. Launch capacity today is increasing, but the numbers are still staggering. Hundreds, maybe thousands of heavy-lift launches over years, and a logistics train for manufacturing, deployment, and on-orbit servicing. Cost estimates vary wildly depending on architecture, from tens of billions for very modest demonstrations to hundreds of billions or more for large-scale deployments. Technically possible? Maybe, over decades. Practically and politically feasible? That's a far harder question. So who would want to do it? And why? Advocates point to three main potential benefits. First, agriculture in high latitudes. In places with long polar nights, extra light could extend effective growing hours for certain crops, potentially increasing yields in local greenhouses. Second, community safety and well-being. Longer, better-lit evenings can reduce accidents, improve mental health for populations suffering seasonal affective disorders, and extend productive hours in remote towns. Third, energy augmentation. In targeted windows, redirected moonlight could increase the effectiveness of some solar generation strategies or make nighttime lighting more efficient in remote regions. But it is not a simple replacement for large-scale baseload power. These are localized, often modest benefits. They don't promise a global cure for climate change. They are tools with specific applications and trade-offs. Now, the politics. The moon is treated as a global commons under international law. Any intentional alteration of lunar reflectivity raises fundamental questions. Who gets to decide? Do nations need consent from potentially affected regions? What about indigenous and coastal communities who may experience changes to night skies or ecosystems? The Outer Space Treaty obliges nations to avoid harmful contamination and to be internationally responsible for national activities in space, but it doesn't neatly resolve a project that changes how a celestial body reflects light back to Earth. Governance options include UN-led oversight, multilateral treaties, or tightly controlled consortia. But each option has pros and cons, and all require transparency, liability rules, and mechanisms for consent and redress. The most compelling objections are the unintended consequences. First, ecology. Many species rely on natural dark cycles. Artificially brightening nights can disrupt migration, breeding, and foraging patterns. Studies of artificial light at night, ALAN, show real biological impacts from even modest increases in nocturnal illumination. Second, light pollution and cultural loss. For many cultures, an intact night sky is a heritage. If parts of the world lose star visibility or experience persistent glint, that imposes non-economic costs. Third, orbital and mission risk. A cloud or swarm of reflectors increases traffic near the moon and could complicate lunar operations, raising collision risks and debris generation that would imperil future missions. And fourth, geopolitical fallout. If an actor unilaterally adjusts lunar reflection, perceptions of advantage or manipulation could spark disputes. A bright idea could become a geopolitical flashpoint. Before any grand effort, compare alternatives. Terrestrial solutions, grid upgrades, energy storage, targeted subsidies for heaters and insulation are often cheaper and faster. Low Earth orbit reflectors can steer light with less travel mass than lunar solutions, but bring their own debris challenges. Space-based solar power is a different architecture with long timelines. The point is trade-offs: cost, speed, reversibility, and risk. The moon option scores high on audacity, but low on reversibility, and low on equity unless governance is explicit and fair. The first, we spoke with community members in regions that might gain light: farmers, indigenous leaders, and small-town residents. Their responses were simple and consistent. If you're going to change the sky, ask us first. Include us in decisions. Disclose the risks. And don't substitute technology for respect. That call for inclusion is as important as the engineering math. They're better. So where does that leave us? The moon as mirror idea is technically fascinating and ethically fraught. If we ever consider altering the moon's reflectivity seriously, the conversation must be global, transparent, and anchored in science, equity, and law, not spun by a single actor with the means to launch optics into orbit. Tell us, if you had one rule to demand before anyone touches the moon, what would it be? Put it in the comments. We'll compile the best and ask experts to respond. Listen, chapter Sources, modeling notes, and recommended reading are linked in the description. Thanks to the scientists and communities who helped shape this piece. This was The Moon as a Mirror, a climate policy case. Subscribe, share, and keep the conversation grounded in curiosity and care. This was